Textile fibers are those which have properties that allow them to be spun into yarn or directly made into fabric. This means they need to be strong enough to hold their shape, flexible enough to be shaped into a fabric or yarn, elastic enough to stretch, and durable enough to last. Textile fibers must be a minimum of 5 mm in length. Shorter fibers cannot be spun together. So, all textiles are made of fibers, but not all fibers can be used to make textiles. For example, cotton plants contain fibers that are strong and pliant enough to be spun into yarn. These are textile fibers. On the other hand, have you ever noticed those little strings in your corn on the cob? Those hair-like structures are technically fibers. However, they are too weak to be spun into yarn without breaking, so they are unsuitable for textiles.
Fibers are divided into two main types. First one is natural fiber and another one is synthetic fiber. Natural fibers are obtained from plants and animals. We get fibers from seeds, vastes, and leaf of the plant. For example, cotton is obtained from seed of a plant. Jute is obtained from bast of a plant, and sisal is obtained from leaf of a plant. From animals, we get silk and wool. Silk is produced by silkworm, and wool can be obtained from the fleeces of sheep, goat, rabbit, camel, etc. These are the types of natural fibers. Now, let's discuss on the another type of fibers. Another type of fibers is synthetic fibers. Synthetic fibers are also known as man-made fibers, means the fibers which are made by humans. For example, nylon, polyester, and rayon, etc. are the example of such type of fibers which are made by humans.
Natural fibers. Natural fibers are those that occur in fiber form in nature. Traditionally, natural fiber sources are broken down into vegetable fiber, animal fibers, mineral fibers. Vegetable fibers are classified as fiber occurring on the seed, such as cotton fiber. Bast fiber or skin fiber is fiber collected from the phloem like flax, rami, hemp, jute. Tendon fiber from stem or leaves, such as Manila hemp, sisal hemp, etc. Fiber of fruit or nuts shells, coconut fiber. Animal fibers. Fibers from animal sources are more properly known as protein-based fibers. They are harvested from an animal or removed from cocoon or web. Protein-based fibers are come from mainly two sources. From hair bulb, such as wool, rabbit hairs, camel hairs, goat hairs, yak hair, etc. From ceratories, such as silk and spider silk. Mineral fibers. Asbestos is the only natural mineral fiber obtained from varieties of rocks. Man-made fibers are synthetic fibers. Textile fibers produced by humans through one or more types of chemical process are called man-made or synthetic fibers. These fibers are produced in laboratory and in industrial manufacturing units. These fibers are produced by polymerization of monomers of chemical compounds. Few common examples are polyester, nylon, acrylic, polypropylene, elastane, polyvinyl chloride, polyurethane, etc. Regenerated fibers. These fibers can neither directly found from nature nor can be produced by using chemical. These fibers are regenerated from natural material using some chemical process. Monomers are obtained by treating natural material with chemicals. Some common examples are rayon, bamboo fibers, modal, lyocell, etc. Non-cellulosic man-made fibers. Azlon fiber from soya and corn casein of milk ground nut. Mineral, glass, ceramic, and graphite. Metallic fibers. By mining and refining of metals like silver, old aluminum, and steel. Rubber fibers. Comes from the rubber tree. Essential properties of textile fibers. Length and breadth variation. Almost all textile fibers have the length to breadth ratio of more than 1000:1. Strength. The strength may be tensile strength, bending strength, bursting strength. A stronger fiber results in stronger yarn and fabric. Uniformity. A fiber possessing this property can produce reasonably even yarns. This is also important in connection with the strength of the resulting yarn. Uniform textile fibers should possess uniformity in their thickness and length. Spinability. Spinability includes several physical properties, each having an effect on the ability of the fibers to be spun into yarn. Staple fibers must have to be capable of taking twist or being twisted. Fineness. The fineness of a fiber is a relative measure of its thickness or diameter. If the fiber is finer, there will be more number of fibers in the yarn cross-section, which will make more surface area available for interfiber friction and thus will provide more resistance to slippage. Due to this fact, the yarn spun from finer fibers will have higher strength. Luster. Natural luster enhances the value of textile fiber, especially natural fibers. For example, the natural luster of the silk gave it for a long time distinct advantage over the other textile fibers. Durability. A textile fiber should withstand processing treatments and should not be easily susceptible to physical, chemical, and bacteriological attack, which may result in damage and decomposition. How viscose fibers are made. At first, wood are chopped into small pieces and processed into cellulose pulp. The cellulose is treated with 17.5% solution of sodium hydroxide, which converts it into soda cellulose. 2. The soda cellulose reacts with carbon disulfide to form sodium cellulose xanthate. 3. Sodium cellulose xanthate is dissolved in a dilute solution of caustic soda and it's form orange honey like liquid. This liquid extruded into sulfuric acid, which regenerates the cellulose, now in the form of long filaments called viscose rayon. At this point, key modifications such as changing the shape and size of the cross-section, while cooperative attitude can be made. Properties of viscose fiber. Viscose is the most absorbent of all cellulosic fibers, even more so than cotton or linen. Viscose gives the appearance and feels so soft and silky and very comfortable to wear. Viscose fibers have good moisture regain property like cotton fibers. Viscose has a good drapeability property. It has good tensile strength and abrasion-resistant properties. Viscose fibers can be easily dyed in several colors. When heating the viscose fiber, it does not shrink. Viscose fiber is biodegradable. Viscose can be blended with some other fibers. With polyester give polyviscose. With cotton give cotton viscose. Also viscose can be blended with spandex for good stretchability. Commercially, viscose fiber known as Zandrel, Avril, Fibro HSO and Grezim. End uses of viscose rayon. The softness, drape and the luster in the fiber make it a preferred choice for ladies' garments and menswear. The most common uses of viscose are in apparels like dresses, suits, sari, lingerie, and children's clothes. It is used in making umbrella cloths and protective cloths. It is used as swing embroidery threads. Uses in curtains, cushions, beach, and sportswear. Viscose is also used in non-woven fabrics for baby wipes, wet wipes, and napkins, etc. What is the difference between viscose and polyester? While many consider the viscose and polyester to be similar, there are a lot of differences between the two materials. Both polyester and rayon are made from long fibers, but polyester is a synthetic fiber, whereas viscose is semi-synthetic, that is using natural fibers but chemicals in the process. Polyester is more moisture-wicking while viscose is more absorbent. Polyester dries faster and does not wrinkle as easily as viscose. Polyester is stronger and does not shrink. Viscose is more likely to peel, whereas polyester resists abrasion. Polyester is made from oil, while viscose is made from plants. Viscose fiber is biodegradable. Most of the polyester are not biodegradable, and polyester production and use contribute to pollution around the world.